Dear students, good morning. Today we'll discuss the mechanism of anionic polymerization, say under addition polymerization. In previous class, you are well familiar with the mechanism of free radical addition polymerization and also cationic addition polymerization reactions. So with that, today we'll discuss about anionic polymerization. Similar to the previous, even here also it involves three steps. Say initiation step, propagation step and termination step. So in the initiation step, which is usually done by the initiators, and here the strong bases are used, and the bases are like say alkali amides, potassium amide, sodium amide or lithium amide, or say organometallic compounds like ethyl sodium or butyl lithium, etc., are used as an initiator. So now the initiator, when they are made to react with the same monomer, there is a formation of active carbon anion. That means carbon ion. For example, butyl lithium, it is used. And as you know, the monomers which are having electron withdrawing group, which are attached to the carbon of the double bond, only those monomers undergo anionic polymerization. Say the butyl lithium, or which acts as a say nucleophile. Here the butyl nucleophile and lithium is carries positive charge, and this nucleophile attacks the carbon atom of the double bond. So now due to the presence of this R, the electron density, that means double bond is rich in electron site, and the electron density will be dragged towards the R, that is electron withdrawing group, and thereby this gets partial positive charge or it is less electronegative, and that will be attacked by the nucleophile, that is butyl group. So thereby we are getting say monomer, and we are getting a carbon ion which is an active species. So when the initiator combines with the monomer, liberates a carbon ion, and which is an initiating chain initiating active species, and that will be produced in the first step, that is initiation step. In the second step, say the carbon ion which is an active species formed with a monomer, so this combines with the number of say monomers one by one and leads to the formation of a macromolecule or a macrocarbon anion, and which is said to be which is active, and it is said to be a growing chain or a living chain, because this is ready to accept many more fresh monomers to give the macromolecule or macrocarbon anion, carbon ion. Okay, so now in the termination step, see the macrocarbon ion is going to be say neutralized by adding proper reagents, and usually here addition of proton will be done, and say like water, alcohol, etc. are added, and where the H plus proton is reacts with the macrocarbon ion and gives the saturated molecule with the formation of say lithium hydroxide. So here the lithium is the counter ion which is always moves along with the negative charge. See here the negative charge along with the carbon ion, the counter ion lithium is also moves throughout the reaction. Okay, so now this is about the say how the anionic polymerization proceeds. Three steps: initiation, propagation and termination. And in the initiation, so these are the reagents which are used as the initiators. Okay, they are the basic in natures, strong bases, and the group present on the carbon of the double bond is electron withdrawing group, and thereby the nucleophile, that is say the alkyl or aryl group of this molecules will attack the carbon of the double bond. So now here, if you look at the movement of the pi electrons, see the pi electron will be shifted towards the say lengthening of direction of the lengthening of the chain. So therefore the shifting is from left to right here. See, it is the moment of or the shifting of electron is in the direction of propagating chain. And whereas in case of cationic, say there is a reverse. The shifting of electron will be like this. Say the ion, carbonium ion, is going to react with the new monomer, and where the electron will be shifted from right to left. So they are opposite. That means the moment of pi electrons during the propagation of the propagating chain is from left to right is in anionic and right to left is in cationic polymerization. Okay, so the in case of here termination process, it is not instantaneous, but in case of cationic polymerization, termination is instantaneous, where the counter ion itself accepts the charge and gets neutralized, and thereby giving, say, the macromolecules or polymers. But in this case it is slow, and the another reagent which is not involved in the reaction needs to be added to terminate the reaction. That means to terminate the lengthening of the chain or to stop the lengthening of the chain, the reagents like water, alcohol, etc., they may be, or ammonia will be added to stop the reaction. Okay, so now in this case, if R is, say, COOCH3, then that molecule is nothing but methyl methacrylate, methyl MMA, methyl methacrylate, and this will be the formula. If R equal to Cl, it is a vinyl chloride. If R equal to Cn minus, it is acryl nitrile. So now with this, we'll move on to the few differences between anionic and cationic, or cationic and anionic polymerization. So under cationic polymerization, the, say, propagating reactive species is carbonium ion, which carries positive charge, and that is carbonium ion. But in case of anionic polymerization, it is a carbon anion. That means that the propagating, that means the charge, positive charge is, say, it is propagating, and here the negative charge is propagating in the form of, say, carbon anion. Okay, and now in case of cationic, R is electron donating group, and in case of anionic, R is electron withdrawing group. So electron withdrawing group stabilizes the negative charge on the carbon ion, and in case of cationic, donating, R is a donating, electron donating group, and which stabilizes the positive charge on the carbonium ion. So in cationic, R is electron donating group, which stabilizes the positive charge of the carbonium ion, and here R is the electron withdrawing group, and which stabilizes the negative charge on the carbon ion. Okay, and now in case of cationic polymerization, say the monomer attacks the initiator. The monomer attacks the initiator. For example, in case of, say, isobutene here, see the electron, and thereby it will be electron, and here the electrophile. So now the monomer attacks. This is the monomer. So in the during the polymerization reaction, the monomer attacks the electrophile. So electrophile, which is, say, initiator here, and like this the shifting or the direction is also opposite, and monomer attacks the electrophile in case of cationic polymerization, whereas in case of anion polymerization, the initiator, that means here butyl itself, it attacks the monomer. So this will be reverse. This is the monomer, this is the initiator or a nucleophile, and the nucleophile is attacks on monomer, where monomer attacks the electrophile in cationic polymerization. Okay. So now the next one we can say termination in case of cation is very easy, instantaneous one, but here it is bit difficult, takes the time, it is very slow. So that means even during the termination the chain remains active and the process is also quite slow. Now effect of temperature. In case of cationic, low temperature increases the rate of polymerization. So the polymerization reaction usually favors a low temperature, or at low temperature polymerization proceeds. But in case of anionic polymerization, as the temperature increases, rate of polymerization increases. Okay, and now during the this process, the rate of polymerization is slow in case of anionic polymerization, and in case of cationic polymerization it is fast. Okay, so now with this we'll discuss in the next class. Thank you.